Sigma and pi are first encountered as labels for bonds in the alkenes topic of your chemistry A level, and exam questions asking for the tally of each within a structure is becoming more and more common, especially in the multiple choice questions of the OCR A specification papers. Here in this tutorial, I'll give you a quick guide and some exam tips to tackling these scenarios. Make sure you check the video description for updates, further information, chapters, and their timestamps. First off, what's the difference between the two types of covalent bond? Well, sigma bonds are the strongest type of covalent bond in chemistry, and we use them all the time as they're very common and they're formed by the overlap of orbitals between the atoms. So here in this structure, and I'm using this to show the formation of a pi bond, we can see there are already sigma bonds inside the structure. Between the two carbon atoms, there's a sigma bond. Between the carbon and the hydrogen, there's a sigma bond. And between the carbon and any other group, there would also be a sigma bond. Single bonds in chemistry can be seen as sigma bonds. But what about pi bonds? Well, first off, pi bonds are weaker and just a bit different with their orbital overlap. Specifically, they are formed by the sideways overlap of p orbitals above and below the atoms to create one pi bond. So here on this left-hand side of the diagram, showing the pi bond formation between the carbon atoms, you can see I already have my sigma bonds in place, and on each carbon atom, there is a p orbital that you can see drawn in the green and drawing your attention there by the blue. And what we're going to see is that these p orbitals above and below the carbon atoms, they're going to overlap sideways above and below. And so here in the end product, kind of the after, we can see here we've got this overlap above and below represented by the green eclipse shapes just there. Now that overlap above and below only creates one pi bond. It looks like two, so maybe you're thinking, is this a triple bond that you're forming? But actually the simultaneous above and below sideways overlap of the p orbitals only creates one bond. I think that's best represented by this image down here. When we show a double bond between carbons in organic chemistry, what we're trying to say here is one of the two lines is the sigma and the other of the two lines is the pi. A big misconception is that the whole double bond is a pi bond, but that couldn't be further from the truth. With this theory in mind, let's have a tackle of this particular skeletal structure in determining how many sigma and pi bonds it has. In the exam, they like to ask you to find all of these sigma and pi bonds from a skeletal molecule, and this can be quite tricky as you don't immediately see all of the bonds that it has, since the CH bonds aren't shown in skeletal. My recommendation is to draw out all the bonds in full displayed formula like I've done here, and then tick your way through the structure, finding all of those single sigma bonds. So I'm going to go all the way through here. I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So in this structure, I was able to find 15 sigma bonds. And you'll notice what I did when I came to the double bond. I highlighted one of those lines used in the double bond as the sigma, because what I'm going to do next is identify the other as my one pi bond in this molecule. This is really common in the multiple choice questions. You get a little table and you're asked to select the option with the correct combination. And what the examiner's report tells me is that lots of students are identifying the double bond as just pi, so they're often falling one short in their sigma count. I hope this clears up exactly what you would need to do in the exam when presented with this kind of question and gives you a difference, or a set of differences in fact, between the sigma and the pi bonds. If you did find the video helpful, I would really appreciate it if you could leave it a like before you go to let YouTube know I still exist. And until next time, happy revising.